Okay, so we have a series of rules that will tell us when a precipitate forms. Now, you really have to work at studying these rules, and you have to learn the rules. So, compounds that contain these ions listed below will generally dissolve in water, and when they stay dissolved, they just break apart and float around as ions. So the alkali metals, and remember, who are the alkali metals? The hydrogen family, right? Including hydrogen, even though it's not a metal, it's in the alkali metal family. The nitrate ion, and ammonium, NH4+. So these are the cations. So if you have an anion that you want to get in solution, you hook it up with one of those cations and the material will dissolve. The rest of these are anions. So if you have a particular cation that you want to get into solution, an iron ion or whatever, then you hook it up with one of these. The nitrate ion, NO3-. The halides, what are the halides? Halides are halogens. They're the halogen ions. Chloride, iodide, bromide, fluoride, the halides. Now, these will dissolve most of the time, but when they hook up with silver, lead-2, and mercury-1, then they don't dissolve. Those actually make a precipitate. And you're going to see that later today. It's going to be some pretty cool chemistry when we go to lab and you start mixing two clear solutions and bam, you get a precipitate. Just a chunky solid falling out. It's pretty cool. Sulfates are usually soluble, except when they're hooked up with strontium, barium, and lead-2 and calcium. So we have some weird exceptions in there, but these are the things that are generally soluble. Now, we also have a list of ions that are generally insoluble. If you want to get these insoluble ions in solution, you have to hook them up with something from this list. So, carbonate, CO3, 2-, chromate, CrO4, 2-, phosphate, PO4, 3-. Sulfide is generally not soluble. However, calcium, strontium, and barium sulfide are soluble, and then any others from the soluble list up here will make the sulfide dissolve. And hydroxide, generally insoluble unless it's hooked up with calcium, strontium, barium, or any of the cations from up here. So, it's kind of crazy when you're first looking at it, and it takes a lot of practice with this to be able to recognize this in order to write these double replacement reactions. So, these solubility rules become important in the double replacement that we already discussed at the top of the page. So, we trade partners at the dance, and then we decide, is there any real chemistry? Did anybody leave the dance floor and go behind the bleachers? Did they fall out of solution as a solid? Did they evaporate by bubbling out as a gas? Or did they hook up together and float around as a weak electrolyte, something that stays together? So you have to write the proper formula for each of these compounds when you trade partners at the dance. So let's look at this. Silver nitrate and sodium carbonate. First thing we do is look at this, and in your head, you break it apart into the two ions. Now, this is where that awful nomenclature comes back to haunt you some more. If you don't recognize those ions, you're not going to know how these things break up. So if I look at this, I say, okay, silver nitrate. I have a silver cation, a nitrate anion, and sodium carbonate. So sodium is the cation and carbonate's the anion. Now I have to recognize the cations and their charges. They trade partners. So silver is going to hook up with carbonate. Now, what's the charge on a silver ion? +1. +1. And what's the charge on a carbonate ion? -2. So I have to write the proper formula for silver carbonate. Ag2CO3. So we trade partners writing the proper formula. Now, what's the charge on a sodium ion? Alkali metal. +1. So, what's the charge on the nitrate ion? -1. So I write the proper formula for sodium nitrate. So the first step is trade partners writing the proper formula. The second step is to balance the equation. Well, I have 2 sodiums here and only 1 over here, so I need a 2. Now I have 2 nitrates and only 1 here, so I need a 2 in front of the silver nitrate. And now when I check, I'm balanced. 1 carbonate, 2 silvers. So everything is balanced. The last step, and the one that I think is the hardest when you're learning as a beginner, and this stays hard later because you have to remember, is to now include the subscripts indicating physical state so we can decide, did any real chemistry take place? So let's look at silver carbonate. Do we really have any rules on page 5-8 for silver? Not really. I mean, it's only as an exception, right? But I have a rule for carbonate. What's the rule for carbonate? Insoluble, unless it's hooked up with something on the soluble list. If you have a soluble and insoluble together, soluble wins. So this will be a solid. It will sink to the bottom of the beaker. What's the rule for sodium? It's soluble, so this is dissolved in water, so we write AQ. So now I have a balanced, completed double replacement equation with proper subscripts. So what am I expecting from you by the time we have the test on segment 5? I expect that you will be able to look at these and complete them, balance them, and write the proper subscripts. Okay? In order to do that, it takes a lot of practice and a lot of studying. And if you were slacking off and didn't get those ions down during the nomenclature studying, you better pick it up, because if you can't recognize the ions, you're not going to know their charges and you're not going to be able to write the formulas. You'll really be stuck again. Okay, so let's look at this one. Barium chloride, potassium chromate. So what does barium do? Who does it hook up with? Chromate. Okay, barium chromate. And what does potassium do? Hooks up with chloride. Potassium's a +1, chloride's a -1. Barium was a +2, chromate was a -2. So I wrote the proper formulas. Now I have to balance my equation. I have 2 potassiums, so I'll put a 2 here. That gives me 2 chlorines. I have 2 chlorines, so I'm good there. 1 barium, and then 1 chromate, 1 chromate. So I now have a balanced equation. Now I'll put my subscripts in. What rules do I know about barium? Anything? Not really, right? Do I know a rule for chromate? Chromates are insoluble, so this is a solid. I always found that confusing because insoluble is an S, and it seems like soluble should be S, but the S means solid, okay? S means solid. And KCl, do I know a rule for potassium, an alkali metal? Soluble, so it's aqueous. So when you think about this, when you're trying to figure out what's going on here, barium wants to hook up with chromate, but it has to get into solution to do that. Okay? I never made it to any of the high school dances, but when we were at this dancing class, if there was somebody that I wanted to hook up with and dance with a little bit, not hook up the other way. We didn't do that then, all right? I would go and dance with somebody that was maybe my friend that I was comfortable with, and then I would try and steal the lead and shove us over closer to somebody else. So when that bell rang, I could just trade partners and dance with the person I really wanted to dance with. So you think about that is you have to get in the beaker. So we use the solubilizing ions to get things in the beaker. Just like if you wanted to go to the dance and try and dance with somebody else, you could ask the girl next door for the date, right? And get her to go to the dance with you, and then you could dance with whomever. So when you're thinking about who can be your date to get you into solution, the alkali metals are always a good choice. If you have a cation from the alkali metals, it will get any anion into solution. Okay, sodium works really well. Sodium is cheap and it's readily available. Okay, just kind of like the girl next door. You could just ask her to the dance and then go and trade and dance with whomever, right? Well, it depends where you live if the girl's cheap and readily available, but sodium's always available. If you need to get a cation into solution, nitrate is a good choice because nitrate dissolves all the time. There are no exceptions. So those are two good choices to remember. Now, for now, just pause here and let's go ahead and have you do these two at your seats.